now let's jump into the ecosystem of Spark. Okay, so when we're saying ecosystem, that's mean what we can do using Spark. I mean, what we can process Spark SQL. Okay, we run SQL queries, right, in different databases. We can do the same in Spark also. I mean, suppose we are developing a script in Spark. Okay, we can put their uh, SQL. We can use their SQL also. For that, we just have to use Spark SQL. So that basic symbol is there, spark.sql. In the bracket, you have to put the SQL query. Like, for example, select star from the table. Okay, just like that. Streaming. Spark streaming help us to process the real-time streaming data. Suppose some data is getting collected in the Kafka. Okay, now that is the real-time data, right? And every 10 seconds we are taking the data from Kafka and putting that into S3 bucket or somewhere else. Okay, now suppose in Kafka, what data is getting collected in every 10 second. Okay, suppose 1,000 record is getting collected within 10 second. Okay, and after 10 second we are pulling the data and putting the data into S3 bucket. Okay, we can put Spark in the middle. Okay, and we can request Spark or yeah, we can request Spark to pull the data from Kafka and put the data into S3 bucket. Okay, and in between, if we want to do some analysis, and suppose there is some number, there is some price. Okay, or sales amount. Okay, we want to calculate in between what is the average sell price of every 10 second. Okay, we put a comment for that. I mean, what do you say, function or formula for that, or computation for that, and we can calculate that. And based on that, we can create another column in that particular database or data set. Okay, and put the data in the S3 bucket. So that's the use case of Spark streaming. Spark mlib help us with machine learning things, and Spark grabs. So see, these three things you will not need that much. Yeah, this Spark streaming for, yes, if there is any streaming job, that case you will need. But Spark SQL, if you have SQL knowledge, then you will get to use this too much. Okay, what type of languages we can use in Spark? So we can use Java, we can use Scala, we can use Python, we can use R. There is four languages which we can utilize while using Spark. So we are learning Spark, so it is important for every one of us to know Python, if not in very advanced level, at least in basic level. Okay, so the thing is, guys, I am going to help you here regarding Python a bit. So the best way when I learned Python was W3 school. Okay, I'm sure most of you know about this, but still, to help everyone, I'm opening this. So Python tutorial. Okay, you don't have to learn too much, just till here, or if it's possible till file handling a little bit, and pandas will be available here, I think. If not, you can search here, and somewhere it will be definitely available. But it is important to know at least till this. Okay, the first Python tutorial, till string formatting, till here you have to learn it. Okay, here you will get lots of things to learn, and it is not very difficult. See, here it is showing how you can start. I mean, print, how to do the print. Okay, if I click here, I can see this comment will print this. Okay, if we want to change here and just want to put hello, okay, and run it, we will be able to see what it can do. It's printing hello. Okay, so it will give us idea, the basic idea how Pythons work. what is string, what is number, what is data type, what is loop, what is list, tuple, dictionary. It will set, it will give us the idea. Those are the things we need to know. Okay, for loop, while loop, how it's work, it will give us the idea. Date function, math, how it's work, we need to know these things. I hope till this point everyone clear. If any have you have any question, you can ask me. No, right? Okay, let's move to a very important point of Spark, that is data frame. What is data frame? Okay, don't think too much, just take it like data frame looks like a table where we have rows and we have columns. I'll not explain you what is RDD, because you can just go ahead and search, or the page I sent you last day, there you can search or get the understanding of RDD a little bit. Nowadays, we don't use resilient distributed dataset, right? Nowadays, we don't use RDD too much because we already have the better optimized version of that, that is called DataFrame. Okay, this is more optimized. Okay, so we use, and it looks good also. That is very important while doing anything or with anything. Okay, so it is basically table format, and it will give us a great view and the optimizations also. So what is data frame? Data frame is a distributed collection of data organized into named columns similar to a table in a relational database or a pandas data frame. If you know panda and if you know pandas data frame, it looks like the same. Or if you don't know it, take a table in the picture. If it look like a table, it built on top of Apache Spark and provide an efficient way to process large scale structure and semi-structured data. So now the point is, if you know table or pandas data frame, it looks like the same in Spark data frame, but are they same? No, they are not same. They looks like similar, but Spark data frame is more optimized. It, you can save a Spark data frame partition wise. Okay, that option don't we don't have available, we don't have available in pandas. Okay, so partitionally you can work on it. Okay, so it is resilient. What Punito was saying about RDD, that features also available in DataFrame. So DataFrame is, according to me, DataFrame is better version of RDD. Okay, it is resilient, we can work on it distributedly. Okay, let's discuss some benefits or key features of DataFrame. Distributed and scalable, can handle petabytes of data using Spark distributed computing. I mean, I hope we all understand petabytes of data. Okay, schema base supports structured data with a predefined schema. So we'll learn in future how to define a schema. In Spark, we can define a schema, and according to that, we can read the file. Suppose we are reading CSV file. Before reading the file itself, we can define the schema. When I am saying schema, that's mean the data types. If any particular column is string or integer or date or something like that. Okay, and the column names also, we can define the schema. Support multiple data sources. Yeah, Spark data frame, while reading in Spark, you can read different type of files like CSV, JSON, Parquet, Avro, ORC, or you can read data from JDBC. I mean, suppose your data is in Snowflake or Redshift. Okay, you can use JDBC connector and easily read that particular table using Spark. Okay, and then it will convert that data which you are reading into a data frame for further processing. SQL integration allow running SQL query, which I told you. Here is the syntax of the SQL query. I mean, it will be like this: spark.sql. In here you can put like select select star from whatever table. Okay, so you can write the query like this way also. Okay. Okay, support complex transformation. So what is transformation? Will uh, I hope we all have idea. In next slide we'll discuss that. Just for now, no. It's suppose complex transformation like filtering, joining, group by, etc. If we have knowledge already about SQL or Python, I hope everyone know SQL at least here, right? Or at least have idea.
Yes, Ganesh.
Okay, that's good. So yeah, that complex thing you can do here. Fault tolerance is use RDD lineage to recover lost data automatically. And next one task is you need to research about fault tolerance. Okay, what is fault tolerance? How it's work? Very simple thing. Just read by yourself this particular thing. It will stuck in your mind. Okay, you will never forget it. Okay, transformation and action. What is transformation? Definition. Transformation create a new data frame from a existing one, but do not execute immediately. So suppose you have a data frame now. Consider that as a SQL table. Okay. You have a data frame now. Now you want to process anything in particular data frame. Like you have data frame. You want to put some filter in that. You have an employee data frame. Okay, and from there you want to pull the data of each employee who stay in Bangalore. Okay, you can easily do the transformation in that particular data frame which you have. But here remember this line: transformation create a new data frame. So your transformation which you will do in that particular data set, it will not be there in the particular or existing data frame. It will create a new data frame, and next step you have to work with the new data frame. Okay, so suppose you have a table, you are doing some transformation and selecting some data, suppose employees who belongs to Bangalore. When you will run the query for this, it will create a new data frame. Okay, like you have table in SQL, so just like that. Okay, so it will create a new data frame. Why we are calling it lazy? So suppose we wrote a script there, we put some transformation for filtering. Okay, and when we are doing some filtering, our expectation is we'll run the query and it will just filter the data. But no, in Spark it doesn't work like that way. Spark, any transformation will happen only when we'll call action. Okay, we'll discuss that what is action and lazy evolution a little bit more in next slide. So what are the transformation we have? Filter, suppose example of transformation. If you know SQL, you use where clause to do the filter. Filter row based on a certain condition. Suppose filter where the salary is greater than 5,000, or filter where the city is city equals to Bangalore or Kolkata, whatever. Okay, we all know what is select, because if we know SQL, we wrote multiple times the select statement, like select uh, first name and last name from this particular table. Like that, we also do the same here. Group by, If you know SQL, you have used group by to group certain data and do the aggregation. Same here, you have to do group by on some columns, and for that you have to do aggregation also. To do group by aggregation also important, as we know from SQL itself. So see, as last day I was saying, syntax and all this is less important than the knowing how it's work internally. Okay, because this thing, tell me now, out of this four, what if you have worked with SQL, you have done all of this already. Okay, but yes, those same thing we can do as transformation in Spark also. Okay, with column will help us add or modify a column. So if we want to add a new column in Spark, there we have a pre-built function called with columns. With column, this will help us to do that manipulation. Okay, but again, two things: it's a lazy evolution, or and whenever you will create transform a data frame, that will create a new data frame from the existing data frame. Action, let's discuss what is action. So I'll, don't worry, I'll provide you the enough example of this. First, I'm going through the theoretical part, and I hope everyone has the have logged in or signed in Databricks itself. Okay. So action is trigger, execution, and return result or save data. What action do? Suppose you have done above transformation. Okay, it will not perform then and there until you call a action like show or count or collect, something like that. Okay, will not be able to see the result. Okay, in production we don't do these things too much, but this action we do at the end of the script to write the file. Write and write dot save, it saved the data frame to storage. Suppose we perform all the transformation, required transformation, we are first reading the file. Suppose, let me start from the beginning. Suppose we have a CSV file where we have student data or employee data. Okay, now using Spark we read the file. Now we'll do some transformation on it, and we need to, after the transformation we need to write the file in a particular location. I mean, in simple term, it is saving the file in a particular location. Okay, taking the file from somewhere, doing the transformation and saving the file in a particular location, that called write. Okay, and reading, read means we are taking the file from a location and converting that to a data frame. Okay, so yeah, those are this the very mandatory, right, mandatory action which will take while doing production or development. But yeah, so count, those are also transformations. Okay, collect first, so will help you to display the data frame. Count, return the number of rows. Collect, we don't use collect too much, but because there is some restriction of use collect, and there is some optimization issue using collect, because it's collect all the data in the driver itself. Okay, I'll explain this later part. Retrieve all data to the driver. Okay, okay, let me explain you a little. Okay, here, how collect work and what is optimization, or how our job can get failed. So suppose we have four jobs, we have 100 GB of data. We divided that into 25 GB each and move that to each executor to process. Okay. Now, when you will call collect to see the data, okay, if you call collect, 25 GB, 25 GB, 25 GB, 25, 100 GB of data came into, will come into driver memory. Suppose our driver memory is also maybe 50 GB, okay, or 40 GB. Okay, now 100 GB file, if driver memory collecting the 100 GB of file from all the executor, then the size will become, driver memory has 40 GB and the total size of the data is 100 GB, then it will collapse, right? So that's the issue with collect. We basically don't do collect too much. Okay, now we come to lazy execution. So till now I already explained that. Just I'll read this. Lazy execution means the PySpark does not execute transformation immediately when they are called. That's mean whenever you will just write transformation, it will not just go ahead and do the transformation. It will do the transformation only if you called a action. Instead, it built a logical plan and wait until an action like so collect, so count or write. Okay, in that case, is trigger to execute the transformation efficiently. Okay, till now, any question before I move on to practical part a little? Any question from transformation? Why it is important, you are saying?
Yeah.
Yeah, see, whenever we are doing a transformation, okay, in our main script there will not be one transformation only. Okay, there can be multiple transformation. Okay, it will not be like that. Yeah, Spark will just go ahead, utilize the resources, and just transform that. Spark has its own brain. Okay, Spark know how to optimize thing internally. We can write the code as per our understanding, but Spark will take all the transformation together. It will optimize that internally. We also need to optimize, but Spark also do catalyst optimization inside its memory. Okay, I mean it will plan that. It will take all the transformation and it will think which part I need to do first, which need to do second and third. It will plan this way. It will plan, suppose it will prepare four plan, execution plan. Now it will check what is more cost optimized out of this four, which will use less resources, less time. Okay, according to that it will make the plan, and when you will call the action, that time it will process the whole thing. So that's the reason evolution or execution is important.